In the silent depths of Siberia, winter never truly ends. In the far northeast, the ground remains locked in permafrost, a layer of soil frozen since the last ice age. Beneath this frozen ground lies a vault of ancient secrets: seeds, spores, bones of long-lost beasts, and astonishingly, tiny creatures waiting to awaken. It was in this cold, remote wilderness that scientists made a breathtaking discovery: a microscopic worm frozen in Arctic ice since the late Pleistocene, stirring back to life after 46,000 years of dormancy. The saga began at a site called Duvany Yar, a permafrost outcrop on the Kolyma River in northern Siberia. There, years of erosion had exposed ancient frozen sediment. In this sediment, researchers found a fossilized burrow left by an Arctic ground squirrel tens of thousands of years ago. The burrow, entombed deep in the permafrost, contained a cache of Ice Age plant material, bits of grass and seeds, and something unexpected: tiny nematode worms, locked in the ice alongside the squirrel's nest. The sample of frozen soil was carefully collected and stored. In 2018, Russian scientists in a Moscow lab gently thawed a bit of this permafrost and observed it under a microscope. To their astonishment, one of the long-frozen nematodes woke up. The tiny roundworm began to move and eat, slowly wriggling back to life after its millennia-long slumber. In the following days, it even reproduced, bearing new offspring despite having been in suspended animation since prehistoric times. "We can say that they're alive because they move, they eat, and they reproduce," commented Philip Schleifer, a biologist on the research team. Indeed, the revived worm's emergence marked the first evidence that a complex, multicellular animal could survive tens of thousands of years in deep freeze and return to life. To verify the worm's astonishing age, scientists analysed the surrounding material. They performed radiocarbon dating on the burrow's plant fibres and seeds, which revealed that the sediment had been frozen for roughly 45 to 47,000 years, dating back to the late Pleistocene. In other words, this little worm last wriggled on Earth when woolly mammoths roamed the Siberian tundra. It had remained in a frozen trance since the Ice Age, never thawing until modern researchers revived it in the lab. But how could a worm survive being frozen for 46,000 years? The answer lies in the survival strategy known as cryptobiosis, essentially life in suspended animation. In cryptobiosis, an organism's metabolism shuts down almost completely. It neither ages nor grows. It is, to all appearances, lifeless. This state allows certain hardy creatures to endure extreme conditions that would ordinarily be fatal. For example, tardigrades, commonly known as water bears, can survive total dehydration by curling into a dormant ton form. And brine shrimp eggs or plant seeds can remain viable after centuries of dormancy. The Siberian nematode appears to have done something similar on a far grander timescale. Faced with freezing temperatures and a lack of liquid water, it entered a cryptobiotic state and effectively paused its life. When an organism undergoes cryptobiosis, it activates special biochemical defenses. The nematode probably expelled most water from its cells and produced protective compounds like trehalose, a sugar known to stabilize tissues and act like a natural antifreeze. In laboratory tests, the researchers found that if the worms were first gently dried out and then frozen, they had a much higher survival rate, suggesting that preemptive dehydration was key to their endurance. Both the ancient Siberian worms and modern lab worms were observed to ramp up trehalose production under those conditions, which helps prevent ice crystals from shredding their cells. Essentially, the worms shut down their metabolism and waited out the Ice Age in a state of suspended animation. In cryptobiosis, time nearly stops. No growth, no decay, until warmth and moisture return to jumpstart life again. Scientists were awed by this feat. An organism as complex as a nematode, with nerves, muscles, and a digestive tract, surviving on a geological timescale, truly stretched the limits of biology. One expert called it mind-boggling to see a multicellular animal come back after appearing dead for millennia. Indeed, the revived worm demonstrates that life can be incredibly resilient, teetering on the edge of death for ages, yet still capable of resurrection when conditions improve. This video is sponsored by Odoo, and today I want to highlight their powerful CRM application that helps you stay focused on what actually matters: closing opportunities. If you're running a business, whether you're selling software or shipping out inventory, Odoo CRM app keeps your entire sales pipeline right in front of you. Every lead shows up as a card with the essential details, and you can move them through your pipeline stages with a simple drag and drop. It's fast, it's visual, and it keeps your team in sync. Need to follow up? Odoo's got your back. You can schedule calls, emails, meetings, whatever your sale process needs. And Odoo automatically plans the next activity, so you're always one step ahead. You'll also love the built-in communication tools. Every message, every email, it all lives in one place, so nothing gets lost in the shuffle. And when it's time to send a quote, it's literally a couple of clicks. Pick your products, hit send, and Odoo handles the rest. Professional, clean, and fast. Plus, Odoo gives you real-time data, AI-powered lead scoring, and automation tools to cut out the busy work. So try it out for yourself. Click on the link in the description and see how Odoo's CRM application can streamline your sales process. Thanks again to Odoo for sponsoring this video. Once the nematode was revived, the next challenge was to identify it. A global team of scientists soon confirmed that it was a previously unknown species, which they named Panagrolaimus kolymaensis, in honor of the Kolyma River region of Siberia. The Russian researcher who first revived the worm, Anastasia Shatilovich, joined forces with German colleagues to sequence the worm's genome and compare its features to known species. They discovered that P. kolymaensis reproduces parthenogenetically, meaning the females produce offsprings without males, a finding consistent with the fact that all the revived worms were female. In the lab, the ancient nematodes even thrived. The team was able to culture over 100 generations of P. kolymaensis from the original specimen. This allowed them to observe the nematode's life cycle and survival traits in detail, essentially watching a lineage that began in the Ice Age continue into the present day. The resurrection is more than a curiosity. It opens new avenues of thought in science. For biologists, it extends the known limits of animal dormancy by tens of thousands of years. It raises fundamental questions about the longevity of life. If a tiny worm can survive in ice for 46 millennia, what does that imply for other life forms, or for even our own cells? Insights from these worms could prove valuable in cryobiology and medicine. By understanding the tricks that allow a nematode to effectively cheat time, such as trehalose protection and other cryptobiotic adaptations, researchers might develop better techniques to preserve biological materials. For instance, long-term cryopreservation of cells, tissues, or organs for transplantation or research is currently limited by ice damage and metabolic decay. Learning from cryptobiotic organisms could help us formulate new cryoprotectants or protocols to store living cells for far longer than is possible today. Some scientists even speculate that unraveling cryptobiosis might one day contribute to preserving human cells or embryos for extended space travel or medical use. A far-off prospect, but one that this humble worm makes a bit more conceivable. The findings also carry intriguing implications for astrobiology, the search for life beyond Earth. If a multicellular creature on Earth can survive 46,000 years frozen underground, perhaps life, even simple life, could endure long freeze-outs on other worlds. Mars, for example, is a cold desert where any microbes might have to persist in dormant states beneath the permafrost. Likewise, icy moons like Europa could harbour life in stasis. The revival of the Siberian nematode strengthens the argument that life could persist, dormant but viable, in extreme alien environments. It suggests that the absence of apparent activity on a planet doesn't guarantee that it's lifeless. Life might just be lying in wait, as it was for ages under the Arctic ice. Finally, this discovery prompts existential reflections closer to home. It blurs the line between life and death, showing that an organism can linger in a twilight state, neither fully alive nor truly dead, for an astonishing span of time. The nematode was essentially in a coma since before human civilization began, yet it retained the spark of life. But that reminder comes with a measure of caution. As permafrost warms and thaws, due to climate change or human activity, other ancient organisms may emerge. Scientists have already revived prehistoric microbes, including a 30,000-year-old giant virus from Siberian ice. Fortunately, that virus infects only amoebas, but it shows that ancient pathogens can survive in ice for eons. The story of this ancient worm's revival is like something out of a nature documentary. Against all odds, and against the flow of time itself, life has prevailed in the permafrost. I hope you found this as interesting as I did. And as always, thanks for watching.